Hello everyone. In this video, we are going to discuss the problem D of today's Codeforces round 831. The problem says we are given a grid of dimensions R cross C, of dimensions N cross M, and in this grid, let's say R comma C represent a cell in the rth row and cth column, and in the cell 1 comma 1, we are given a stack of k cards, and each card is having an integer from 1 to k. And more specifically, let's say this problem is saying that the stack is, let's say it is a permutation of integers from 1 to k. Now we want to find if there exists a way to take these cards to the cell n comma m such that the ith card from the top equals to I, and the movements are given such a way that like we can move one card to its adjacent cell only, and we cannot move a card from one cell to another cell which already where there exists a card already. And for, there are special conditions for cell 1 comma 1 and comma m, like we cannot take a card from any other cell to one cell 1 comma 1, and for n comma m it is given that we cannot remove a card from cell 1 n comma m. So these are the conditions, and we need to find if there exists a way to take these cards to the cell n comma m such that the ith card from the top is equals to I. And in the input we are given this permutation, like how they are stacked in the cell 1 comma m. So let's try to find out a way, if there exists a way such that we can stack these cards in the cell n comma m. Let's say we are given this grid. The solution is actually quite simple. You need to have a basic observation in this problem. You just need, so let's say we are given a stack of cards in this cell 1 comma 1 in this cell. Now first of all, what we'll do is we will take the stack will be, let's say, a1 a2 a3 from top, let's say, up to ak. This will be actually a permutation of first k natural numbers. So first of all, we would like to collect the card k and move this card to the cell n comma m and put it at this cell. So let's say up on top of the card k we have some cards, and we will remove those cards and put those cards in these cells. We can put those cards in these cells, and after taking out these cards we can move the card k. Let's say we have removed some cards, and after removing we have found a card k. Then we will take this card and move it like this and put that card k in this cell. Again, we would like to find card k minus 1. Now let's say the card k minus 1 we have already removed from the cell 1 comma 1. Then what we can do is, let's say this is the card k minus 1. Let's say this is the card k minus 1. Then what we can do is we can shift these above cards in we can shift above cards in the upper cell. We can shift this in the upper cell, and take this card through this and put it on the cell and combine. So in this way, first we would like to put k, then k minus 1, then k minus 2, k minus 3, up to 3, 2, 1. In this way, we would like to put these cards in cell and combine. So we can observe one thing is like we need to find if there exists a way. So we can observe one thing is, let's say if the size of this cell, size of this let's say grid is 1 cross m, let's say number of rows equals to 1, then we can say that the stack we are given, the stack we are given, let's say a should be equal to, it should be equal to k minus 1, k minus 2, 2, 3, 2, 1. Otherwise, our answer will be minus 1. Our answer will be no. There is no other way. And if m equals to 1, m equals to 1, then also the stack should be equal. Stack should be equals to k, k minus 1, k minus 2, up to 3, 2, 1. Otherwise, if a is not equals to this permutation, then our answer will be no. And in all other cases, the only condition is, let's say, if we want to find a number, if we want to find a number, let's say we want a card on which there is written, let's say X, and above this card X, there are T cards. Now T cards, we would like to place these T cards except these two cells. We would like to place these cards in this region. In this, we can place these cards except cell 1, 1 and n, m. Here, here, here. We can place these cards here. But the only condition after placing these cards is we should be able to move this card X from 1, 1 to n, n. This you can observe is we can do if we have two empty cells other than 1, 1 and n, m. If we have two empty cells, then we can do this. Like we can shift the cells and move this particular card to the cell n, m, and again we would like to find the lower card, let's say x minus 1, and similarly we would like to arrange these cards on this grid in such a way that there will be two empty cells, and if we have two empty cells, then we can move this card x minus 1 to cell n, m. So how we will do this, let's see the code in this code. I have used binary index tree. Actually, we do not need binary index tree. If you try to observe this thing is, you can take a count. Actually, the count will be the number of cards you have removed, but those cards are not placed in your cell and comma m. You can also take that count, but I have used the binary index tree, Fenwick tree, to count the number of cards which are not placed on the cell n, m and which occur before a particular index. Let's say we will iterate over I equals to k to 1, and we would like to find a card I from this stack, from the given stack which is present at the cell 1, 1, and we would like to find how many cards come before the card I and that are not placed on the cell n comma 1. Let's say the count is CNT count, and that count, if that count is greater than n into m minus 4, why I have taken n into m minus 4, because there are two cells 1 comma 1 n comma that we are not including in our movement, and beside these two cells we need two empty cells to make a movement of the card from 1 comma 1 to n comma m. So if this count is greater than n into m minus 4, then there is no way to place the cards from 1 comma 1 to n comma m in the desired way. Otherwise, if this count is less than equals to n into m minus 4, then we can move this card to the cell n comma m. So this was my approach. Thank you.